Hi, this is Charmin here. In this video, I'm going to teach you math, that is identify and interpret the intercept of a linear model and calculate and interpret this. Hi, this is Charmin here. In this video, I'm going to teach you linear model, that is intercept, and identify and calculate the interpret of intercept of a linear model and slope of a linear model. Alright, so let's get started. Lesson outlines. Linear models and equations. Interpreting linear models. Can all data sets be shown on a graph in an orderly manner? Slope, the ratio of a change in y to change in x between 2 points in a line, that is a slope. So we need to identify and calculate, and that is interpret the slope of a line, that is the linear model. So here intercept, that is the point where the line intersects the y-axis. So a set of data may be scattered as the one shown in the graph, but can be represented by a line of best fit. A straight line that best represents a set of scattered data. Not all data sets can lead to an ordered set. Line of best fit. After gathering the data, our group drew the line of best fit as shown. Can you identify the intercept? So if you see, here is a temperature and here is a time. So here is over time, temperature is increasing. If you check, if you see the scatter point, so yeah, so that is the line of best fit. In an experiment for our science class, we investigated how fast a given liquid changes its temperature. So identifying the intercept of the line, recall that the y-intercept refers to the point where the line intersects the y-axis. If you see the graph, the line intersects the y-axis at 25. So y-intercept is that is the 25. Interpreting the intercept of the line. So here is a time, that is the 25, that is the degree Celsius, 25 degrees Celsius, that is the temperature. So it's increasing over time. Here is a 0 to 16, and that is the time period minute. So looking at the graph again, we can then say that the temperature of the liquid before heating, so heating is 25 degrees Celsius. So what information can the y-intercept tell us? Y-intercept is also the value of the y when x equal to 0. Looking at the graph again, we can then say that the temperature of the liquid before heating is 25 degrees Celsius. All right. So here is a try to solve for the slope of the line. Calculating the slope of the line. Here is a formula, that is slope m, that is the change in y divided by change in x. So this can be calculated using 2 points on the line with the formula. So slope m, that is y2 minus y1 divided by x2 minus x1. So calculating the slope of the line. So if you know the formula, then you can find. So here is the y2 minus y1, that is y2, that is here is a 40 minus 35. So if you subtract, then you will find. And here also, if you see here, that is x2 minus x1, that is 7 minus 5. So it will be 2.5, that is the slope m. So these slopes tells us that the temperature increase up 2.5 degrees Celsius every minute. So it's a y-axis and this is the x-axis, that is the time, and degrees Celsius here, temperature. So here, equation of the line in slope-intercept form. Equation of a line in slope-intercept form, y equal to mx plus b. So if you use the formula, you can find a calculate and then you get the answer, guys. So equation of the line in slope-intercept form, here is a formula you can apply. So using the y-intercept and the slope, the line of best fit may be represented through an equation. So here you go. So here's a given that b equal to 25, that is the 2.5 equation of the line is y equal to x plus b. So we know that b is a 25. So this equation can now be used to predict the temperature at a given time. So list here, that is the unknown values we need to figure out, and write here how you will solve the equation. Use the remaining space for our solution tips. That is, use the graph from the previous slide as a guide. So activity, using the equation of the line, predict the temperature of the liquid after 15 minutes of heating. So y equal to x plus 25. Temperature, that is y, at 15 minutes using the equation of the line. Activity, using the equation of the line, that is the predict the temperature of the liquid after 15 minutes of heating. So y equal to x plus 25. So if we will here y equal to 20, that is x, we know that 2.5x plus 25. So we will calculate, then we will get y, that is y equal to 62.5 degrees Celsius. So after 15 minutes of heating, the temperature of the liquid is predicted to be 62.5 degrees Celsius. All right, guys, that's all. Thank you very much and see you later.